This video will discuss reduced row echelon form, which you should know can be abbreviated by RREF. The reason why you'll need to know this is because eventually we'll be performing this reduced row echelon form calculation on our calculators, and we should equate that to Gauss Jordan elimination. So I have here the 4 requirements of reduced row echelon form, and an example of an augmented matrix here that's already in reduced row echelon form. And when we transform our matrices using Gauss Jordan elimination, this is the form that we want our matrices to be transformed into, because if we label these columns as x, y, and z, you could see that this first equation is x, or 1x, is equal to 3. So therefore, the first part of the solution is x equals 3. The second equation is 1y, or y, is equal to 4. So the second part of the solution is y equals 4. And the third row tells me z is equal to 5. So I could write it out like that: x equals 3, y equals 4, z equals 5. Or I could write it as an ordered triple, similar to how we write ordered pairs corresponding to a point on a Cartesian coordinate system. In example 3, we should determine whether or not the matrices are in row-reduced form, and if they are, we can give the solution. So what we saw in this matrix was that all the elements in the principal diagonal are 1s, and everything else in those columns containing the 1s were 0s. Again, this is what we want to aim for. So if I look at the first part of example 3, I've got the principal diagonal as 1s, and everything else in those columns is 0. So yes, this is in reduced row echelon form, and the solution is the ordered pair 3, negative 2. Now when we move on to the second part of example 3, if we were to go through our requirements up here, each row consisting entirely of 0s lies below any other row having non-zero entries. Well, that's true. Our complete row of 0s happens on the bottom. The first non-zero entry in each row is called a 1, or a leading 1. We have that. And any 2 successive non-zero rows, well, we don't have 2 successive non-zero rows. And if a column contains a leading 1, which this does, the other entries in that column are 0s, and that applies. So I would say yes, this is in reduced row echelon form, and the system, or excuse me, the equation represented by this is x plus y equals 3. I could come up with a gazillion pairs of numbers that add up to 3. For example, 1 and 2, 2 and 1, 0, 3, 3, 0, negative 1 and 4, 4 and negative 1, and so on and so forth. So this is an example of a system with an infinite number of solutions. Finally, in the third part of example 3, if we examine the principal diagonal here, we have 1, 1, 2. This 2 violates the leading 1. The first non-zero entry in each row needs to be a leading 1, and the first non-zero entry in this row is not a 1 but a 2. So this is not in reduced row echelon form because this 2 should be a 1.